Hey, I've been working on a whole mess of other stuff, but recently I was struck by a thought. You know that question that's like, which weighs more, a ton of feathers or a ton of bricks? And you immediately answer, a ton of bricks, unless you think about it and then you go, wait, no, they're both a ton, they both weigh the same. Right? So, hi, I'm Legion, and a ton of bricks really does weigh more, probably. Let's start with the basics. The density of bricks, according to a random bunch of internet sources, is about 1,900 kilograms per meter cubed, while feathers are about 1,300 kilograms per meter cubed, which is... wait, really? So they're surprisingly close to each other, but the main point is that bricks are definitely denser. What this means is that the bricks will of course take up more space. So if we have a cube of bricks and a cube of feathers, the cube of feathers will have to be longer on every side in order for both of them to weigh 1 ton, which means, and this is the important part, that it's going to be taller. There are other ways you can do this, like having identical footprints, which will make 2 of the sides the same, but will make it a lot taller, or just any way of doing it that makes them basically the same shape and also makes the feather pile taller than the brick pile. Like, they could be similar square-based pyramids for all that matters. Okay, you might ask, but why does it matter if it's taller? Surely it still weighs a ton. Well, here's the thing. Weight isn't measured in tons, that's mass. Weight is measured in newtons, and maybe you're thinking, okay, but doesn't that just mean that we have to multiply the number of kilograms in a ton by 9.81 or something both times? But that 9.81 isn't actually a constant. It comes from this equation. Small g equals big G big M over small r squared, or if you want the weight directly, that equals big G big M small m over small r squared. And if that looks threatening, don't worry, because big G is just a number in some units, and in this case big M is the mass of the Earth, so it's also just a number in some units, and small m is the mass of the object whose weight we care about, which in this case is 1 ton, which is 1,000 kilograms, so GMM is also just a number. Like, sure, it's 3.96 times 10 to the 17 with some units on the end, which we don't need to think about too hard. But we're asking if the bricks or the feathers weigh more, and GMM is the same both times, so it's like, whatever, it could be a tiny number for all we care. The real thing we're saying is that the weight is this thing divided by r squared. So if r is bigger for the feathers, that is for the bricks, that means that the feathers are lighter. And r is the radius of the Earth, which is also basically a constant, except, well, neither of those things is true. First, the radius of the Earth isn't constant, and second, while we like to use the radius of the Earth as a nice approximation, because a few extra meters won't usually change much, r is actually the distance between the centre of mass of the Earth and the centre of mass of the object, which, if you somehow don't know what that is, it's basically like the average location within that object, except that denser parts count proportionally more, and what do you know, the feathers have a very slightly higher centre of mass, assuming that either the shapes are similar, or they are scaled up except for the footprint, or any other method whereby the bigger one has a higher centre of mass, and also that you didn't, like, put a ton of bricks up a mountain or something. It really doesn't make a significant difference, mind you. Like, so, suppose we have a cube of feathers and a cube of bricks, and they both weigh 1 ton. The side length of the cube of bricks is about 81 centimetres, and the cube of feathers is about 92 centimetres. It's still messing with me that feathers are that dense, but I guess it makes sense. Like, they're so light because they're hollow, and the stuff that they're made of can get away with being fairly dense, but it still throws me. Anyway, the centre of gravity is going to be half of that above the surface of the Earth. So if you put both of these at about the lowest Earth radius, and let's pretend it's 6,371 kilometres on the nose, r is 6,371,000.4 metres for the bricks, and 6,371,000.46 metres for the feathers. That means r squared is one number that I'm not reading out for the bricks, and one other number that I'm not reading out for the feathers. So the weight of the bricks is 9,756.182 6 newtons, and the weight of the feathers is 9,756.1824 newtons. It's not a lot of difference. It doesn't even appear until a way lower significance level than I would normally go to. But technically, a ton of bricks really is heavier than a ton of feathers. Probably. Okay, so that was a fun one. I'm actually going to start doing things again on this channel, so like and subscribe, I guess. Bye!